Hey there, Team 12. Shout out here is going to Emily Wilkinson. Don't know why you got the shout out, Emily, but just be happy that you got it. Okay, right, we are going to look at this practice that we did yesterday, and we've got the same points as yesterday. We have to look at total length and total land area. So I'll start with total length, because that's going to be pretty easy. So we need to find this length here, and we need to find this curved length around here. And so I'll start with that straight length first. And the first thing I'm going to do is find this angle in here. Now, because I have a triangle, I can take these two angles off 180, and that leaves me with 65. So that angle there is 65 degrees. Okay, now I'm going to use the sine rule here, so I'll call this side A, and I'll call this side B, and so that'll be capital A there, and that'll be capital B there, and we'll use that to find our length of A. Alright, so I'll write that down here, so I've got plenty of room. So I've got A over sine A equals B over sine B. Now I'll substitute in, so A we don't know, but we know that the angle of capital A is 30, so I've got A over sine 30 equals, and then we've got 69 for B over sine 65. Okay, now we'll do our first step of working, which is to multiply both sides by sine 30 so that they cancel out on the left hand side. So sine 30, so they cancel out. So we have A equals 69 times sine 30 divided by sine 65. Now when you're putting this in the calculator, make sure you've got brackets around the top there, and then you can put that in. Alright, so for that one we get 38.1 metres. So I'll write that in up here. So that side there we can say is 38.1 metres. Now don't get confused by the scale here. That's just what happens with these diagrams. They're deliberately out of scale so that you don't sort of guess what it's going to be. Okay, now we need to find that curved area, and so that's part of a circle, so I'll just call that x, and when we're looking at the circumference of a circle, that's pi 2 pi r, and so when we're looking at just an arc length, that's going to be the angle divided by 360 times 2 pi r, and that gives us the formula theta over 180 times pi r. And so you're given this formula here. You don't have to do that work I just worked out, because you're given that formula. So let's put in the things that we know. Well, we know the angle is 102 degrees, and we know that the length is 50, and so putting that all into our calculator, we get 89.0 metres. So that's 89.0. Now we have all of the measurements for the length, so we can put those together. So I'll do that under here. So track length, and I'll just partition that off. So track length is going to be all of the tracks added to all of the sides added together. So 69 plus 38.1, which we just worked out, plus 89.0, which we also just worked out, plus 80 plus 60, and that comes to 407.3 metres. Okay, so we've done that, we've found the total length, and we've used a sine rule here, and we've found an arc length. And so that's 2 skills we've shown there out of the 3 we need to show for achieved. Okay, so now we can start looking at areas. So I'll break it up into some partitions. So I've got 1, 2, and 3, and I'm going to find each of those areas separately. So I'll start with 1 because that's pretty straightforward. So this would be our angle C, and then we've got A and B, so it's going to be a half AB sine C. So let's do those areas now. So area 1, here we go. So I've got a triangle that looks something like this, 38.1 and 69, with an angle there of 85. And so using the area formula which we're given, which is a half AB sine C, that's going to be a half times 38.1 times 69 times sine 85. And putting that into our calculator, we get 1308.3 meters. Now that's my third skill shown, so actually I've passed at this stage. Alright, so that's area 1. Now next I'm going to do area 3, simply because it's quite easy. So area 3, and I'll draw that triangle out as well. So that triangle looks a little bit like this, where we've got 80 and 60, and the angle in there is 70. And so when I label it, I'll call that A, that B, and that capital C. Alright, writing out our formula again, we've got A equals a half AB sine C, and so that's going to be a half times 60 times 80 times sine 70, and putting that into our calculator we get 2255.3 meters squared, and that's our next area. Okay, so now we want to find the area of 2, which is all of this stuff, and to do that we're going to need the length of this side here, which can be our A, and the length of this side here. Now we have neither of those sides at the moment, so we need to find them. So first of all, I'll go for this side here, and I'm going to use the cosine rule for that one. So I'll draw out my diagram down here. So this is for finding the side length of, what's that side called? Well, we'll call that A, and, well, what shall we call it? I'll call that side Y, since we haven't used Y yet. Okay, so side length of Y. Okay, so I'll draw out my triangle again. So I've got 80, 70 degrees, and 60 meters. And we're working out this, which is Y. So I'll label my triangle. So I'm going to label it A, B, and C, because that's how it's labelled for the Cos rule. And so this here is going to be capital C. Alright, so we need to write out the Cos rule. So that's C squared equals A squared plus B squared minus 2AB cos C. So C squared is what we're looking for, so I'll call that Y squared. A squared is 60. A squared is 60 squared, and B squared is 80 squared. We've got minus 2 times 80 times 60 times cos, and the angle is 70. Alright, putting that all into our calculator, we get 5, no we don't, we get 6716.6, and so now we need to take the square root of both sides, and that means that Y is 82.0 meters. So I'll write that on my diagram now. So that's 82.0 meters. So now I want to find this side, so I'll call that side Z. Okay, so we'll do that calculation now. So I'll seal all that off. There we go. And now we'll go side length of Z. Alright, so I'll draw that top triangle out. So we've got 38.1, and we had 69 there. That was 85, and we're looking for that side. So probably cosine rule here again is the way to go. Or we could use sine rule. Actually, I'm going to use sine rule because that's a bit easier. So I'm going to make this side A and this side B. So that's capital B and that's capital A. Alright, so let's write out the sine rule. So we'll have A over sine A equals B over sine B. So A is our side Z that we're looking for, and that's over sine 85, and that's equal to 69 over sine 65. Okay, one step of working here to solve this for Z, which is to times both sides by sine 85, times this side by sine 85, so they cancel out, and all we're left with is z equals 69 times sine 85 over sine 65, making sure that we've got brackets around the top there for our calculator. Alright, putting that into our calculator, we get 75.8 meters. So I write that on my diagram up here. So that one there is 75.8 meters. Okay, so now that we've got those two sides, we can find the area of that triangle up to here. So I'll draw out a diagram of that triangle underneath now. So we'll say triangle in part 2, and so it looks something like this, where that angle we're told is 63 degrees, and we worked out that this side is 75.8 meters and this side is 82.0 meters. Alright, so the area is given by half AB sine C, so it's going to be a half times 82.0 times 75.8 times sine 63, and that gives us 2769.1. Okay, so what we just worked out was all of the area of this up to that blue dotted line. Okay, that's what we worked out. Now I want to work out the rest of that area that's missing, but so I want to work out this, but because it's part of a sector, I'm going to have to work out this first. So I'm going to work out that, and then I'm going to subtract this. So let's break that up even more. So I'll call that area, or I'll call the whole area 4. So all of that area there is 4. Okay, and then this little area here, I'm going to call that area 5. And so we're going to add area 4, and we're going to take area 5 off. Okay, so let's do that. So area 4. Alright, so we'll draw a diagram. So area 4 looks like this basically. We've got 102 degrees, and we're told that the length is 50, and so the area of that is going to be 102 over 360 times pi times 50, and that comes out to be that's 50 squared, by the way. That comes out to be 2225.3 meters squared. So that's area 4. Now I want to do area 5. So area 5, that looks like this, where that's 102, and each of these sides is 50. So it's a triangle, so the area is going to be a half A B sine C, and I've just put the numbers straight in there, and putting that into a calculator we get 2225 point, no, we don't get that actually, we get 1222.7 meters squared. Okay, so if you recap, up here we want to add area of 2 and area of 4 together, and then we want to take away area of 5. So let's put that together. So total area of 2 is going to be, and that's going to be 2769.1 for the big triangle, plus the sector, which is 2225.3, and then take away the triangle, which is 1222.7, and so that's going to give us 3771.7 meters squared. Okay, so now we've found triangle 1, we've found this area here, and we've found this area here. So our total area is to add them all together, and so we'll write that under here. So total area all up and that's all those areas that we've worked out. So that's going to be, let's see, that is going to be 1308.3 plus 2255.3 plus 3771.7, and that comes out as 7335.3 metres squared. Okay, so that's a real classic example, or a real example of merit at this level, and for excellence you'd be asked to change this in some way and justify that. So I hope this helps, and good luck for your test.